GELR, a bilingual Ewe-English corpus building and evaluation. Abstract. The availability of bilingual corpora greatly favors the progress of research in the linguistic field for popular languages such as English, French, Chinese, etc. But whereas under-resources languages such as U, are confronted with limited or non-existent corpora. But setting up bilingual corpus for a language turns out to be possible with online textual data in several languages. This paper discusses the process of setting up a bilingual Ewe-English corpus by the following stages: data collection, data pre-processing, manual or automatic, and sentence alignment with a quality of 96% on average. The quality of our corpus is assessed by building a neural machine translation system through the Bahdanau Attention Mechanism for each pair of languages. Obviously, the results obtained do not fit into the performance of other machine translation systems, because having an efficient automatic translation system requires a bilingual corpus with very high resources, which is not the case with our corpus that we have created. Gayc Ewe Language Resources is made up of a 26K word U dictionary, a 3K bilingual dictionary and a well-aligned bilingual corpus of almost 4 3K sentences. The output format of our bilingual corpus is TMX. Keywords: bilingual corpus, text alignment, computation linguistic, U language. Introduction. Corpus is an invaluable resource for tasks in areas such as researching knowledge, machine learning, natural and linguistic language processing, VAA. Copyright Ronus, 2000. A text corpus is a very large collection of text, often several billion words, produced by real users of the language and employed to analyze the use of words, sentences of the language in general. Some corpora have a very well-defined scope, journalistic texts and biomedical for instance, while others have a broader objective. There are many different kinds of corpora. They can contain written or spoken, transcribed, language, modern or old texts from one language or several languages. Corpora can consist of texts in one language only or of texts in more than one language. For texts that are the same in all languages after translation, the corpus is called parallel corpus. Our work focus on building a U corpus essentially based on bilingual, i.e. English and U, texts crawled from the web pages, books, articles, as there are few works already done on it. A machine translation system is obviously based on the availability of bilingual corpora. The machine translation system is easier to set up for languages with enough digital resources, because the more digitally presented the language is, the higher the probability will be to have a very large bilingual corpus. Neuronal machine translation is a recently proposed approach to machine translation. Unlike traditional statistical machine translation, neural machine translation aims to build a unique neural network that can be tuned together to maximize translation performance. The models recently proposed for the automatic translation of neurons often belong to a family of encoder-decoders and encode a source sentence into a vector of fixed length from which a decoder generates a translation. Merath, 2020. To provide U communities with tools that will increase the vitality and visibility of their language and support its use in a variety of contexts, as well as to help linguists in their efforts to learn more about human cognition study of linguistic diversity, the GELR, Gayc Ewe Language Resources, project was developed by using bilingual textual data to help in natural language processing and linguistic documentation. To achieve this goal, a critical mass of textual data is required. In this paper, we describe the corpus created for the U language and illustrate our method of evaluating our corpus. The previous work on bilingual corpus building is provided in Section 2. Section 3 is about some basic information on the U language building. Section 4 describes the data collection process and provides a detailed overview of the corpus. In the rest of the paper, Section V and Section 6 is concentrated on the subset used for evaluation. And Section 7 draws a conclusion of this study. Related work. In terms of bilingual corpus, a lot of work has been done with satisfactory results. Felipe and Martin, 2019, they worked on the establishment of a corpus of biomedical abstracts in English, Spanish, and Portuguese. Their corpus is based on the BVS database, which contains biomedical texts from several sources in Latin America and Carib. The corpus contains the English/Spanish, English/Portuguese language pairs as well as a trilingual subset of English/Portuguese/Spanish sentences. They did a careful evaluation of their work through NMT experiments with Open NMT system, presenting superior performance regarding Blue score and manual evaluation. Their work focuses on the BUL BASA corpus, a BASA French bilingual corpus composed of both controlled, illicit, and uncontrolled, natural, speech. Although BASA was an under language resources, but it presents basic grammatical properties fairly well documented, which allows the evaluation of linguistic documentation methods, Hamlawi, et.al., 2018. In this work they have described a set of techniques which was developed during the parallel collection texts for the Russian English language pair and have built a corpus of parallel sentences for formation of a statistical machine translation system. They discussed verification issues, potential parallel texts and filtering documents automatically translated. Their evaluation leads to a quality of 1 million entence corpus which, according to them, can be a useful resource for machine translation research. Antonov and Masiyurev, 2011. Automatic translation is today effective and efficient thanks to this work, especially the creation of the neural cell LSTM, long short-term memory, which offered the possibility of working with relatively long sequences, using a machine learning paradigm by Sepp and Jurgen, 1997, as well as sequence-to-sequence work, based on LSTM, Sutskever, Vinyals, and V. 2014, and especially to the creation of the attention mechanism, which was first introduced by Bahdanau et.al., 2015. The aforementioned works show some achievements in the field of building bilingual corpus. But when we refer to our subject of research, we can observe that there has been no prior work in this context. And the fact of building our U language resources for NLP usage will constitute a first for the U language processing. U language. There are a variety of languages spoken around the world and some of them are known as under-resourced languages because of the little work that is done on it in linguistic terms or because of its low usage rate, unlike the English, Chinese, French or Russian language which have a large user community, such is the case of U. In this section we provide the reader with a brief overview of the U language. U is a language of wider communication in Ghana where it is spoken by 2.25 million people as a first language and by another 500,000 people as a second language, Eberhard, 2020. The language is used in daily activities, such as in markets and in the areas of traditional culture and religion. It is taught in primary and secondary schools across the country. It is also used in print and electronic media. In Togo, U is spoken by 2 million people as a language of communication in Togo. It is the predominant language in the south of the country where it is taught in primary schools. It is used as a lingua franca by speakers of different languages in central Togo. It is also used on radio and television, as well as in newspapers. U has 3 distinct dialects. Most of the differences between the dialects are related to phonology. All dialects are mutually intelligible. The written language is based on the Alo spoken along the coast between the mouth of the Volta and Loma A copyright. First, we eliminated the special characters from each collection to simply get the text content, for example, delete smileys, etc., and make sure that the special characters needed are in their place. Although the alphabet of the U language is based on Latin, it has certain peculiarities with certain letters which are often misinterpreted by the computer. These letters are shown in Table 1. U is mainly a nasal tongue, hence the presence of the tilde which marks nasalization. In second position, we set up a new English dictionary by making use of MySQL with the words of the websites which we obtain thanks to crawling. Then we will proceed to text alignment. There is a various methodology for text alignment such as sentence alignment, word and expression alignment, clause and sentence structure alignment and structural alignment, but for our study we will choose sentence alignment. There are several documented algorithms and tools available to perform sentence-level alignment. They can be divided into three categories: based on length, based on a dictionary or lexicon, or based on partial similarity. Text alignment. There are several types of alignment that can be done on textual data, namely document alignment, paragraph alignment, sentence alignment, and word alignment. In our work we opted for the sentence alignment technique. Generally, sentence aligners take as input the texts to be aligned and, in some cases, additional information, such as dictionaries, to help establish matches. A typical sentence alignment algorithm starts by calculating the alignment scores, trying to find the most reliable initial alignment points labeled anchor points. This score can be calculated based on the similarity in terms of length, words, lexicon, or even syntax tree. Tiedemann, 2010. After finding the anchor points, the process is repeated, trying to align the midpoints. Typically, this ends when no new matches are found. Alignment is performed without allowing cross-matching, which means that the sentences in the source text must match in the same order the target text. Our sentence alignment is composed by three files: two plain text files containing uText as the source text and English text as the target one. It contains a sequence of pairs, S1, T1, S2, T2, S3, T3, SN, TN. Each SITH segment in the source text has its beginning position given by SI, and the end position given by SI plus 1A1. The corresponding segment in the target text is delimited by TI and TI plus 1 minus 1. For sentence alignment, we use the LF alignment tool, a wrapper around a Neuronal algorithm, which provides an easy-to-use and complete solution for sentence alignment, including preloaded dictionaries for several languages. Neuronal uses sentence length information from GELR to automatically create a dictionary based on this alignment. Once the dictionary is constructed, the algorithm realigns the input text in a second iteration, this time by combining the sentence length information with the dictionary. Parallel summaries are provided to the aligner, who performs sentence segmentation followed by sentence alignment. After aligning the sentences, the following post-processing steps were performed: I. Deleting all non-aligned sentences. 2. Deletion of all sentences of less than 3 characters, as they are likely to make noise. Output of Gayc Ewe Language Resources. The output of our corpus is in the form of a bilingual Ewe-English corpus in TX format with a creation date, creation ID, and text type, U dictionary of more than 26K words, a bilingual Ewe-English dictionary of more than 3K words, as well as annotated data for U part of speech tagging. Description of the build corpus. The textual resource constructed is a bilingual Ewe-English corpus composed of a total of 1,185 texts collected mainly on the Holy Bible New World Translation texts and articles published on several websites, especially the Jehovah's Witnesses one site, which is a real gold mine for the work of NLP because there are a multitude of publications in more than 300 languages, and Gayc Ewe Language Resources, a website for some U-texts collection. Jude copyright, 2010. Most articles in the GELR corpus are open access documents. In order to avoid any copyright issues, we include in our datasets only open access documents. Evaluation. The last step in the process of creating parallel data qualified as a data set for a bilingual corpus is to ensure that the extracted sentences are aligned with the best possible quality. High alignment quality is crucial for obtaining good SMT translation results. Bearing in mind that manual checking and automatic alignment assessment are time-consuming, it is the alignments of identified parallel documents that are of the highest possible quality. In Torel, Poch, Pechina, and Thutmeyer, 2012, they have integrated a range of advanced technologies, phrase and word aligners in the web service architecture. The state-of-the-art sentence aligners such as Neuronal, GMA, and BSA were evaluated. Our experiment is processed in 2 steps, first step for manual evaluation and second step for neural machine translation. The dataset used is provided by the GELR and consists of 200 sentence pairs of Ewe-English for manual evaluation and 2000 sentence pairs for neural machine translation experiments. We have worked on a model that translated from Ewe to English. Manual evaluation. To assess the usefulness of our corpus, we ask some people with good knowledge of both Ewe and English to subsequently carry out a manual evaluation. Knowing that the Neuronal algorithm generally has good alignment between sentences, we also performed manual validation to assess the quality of the phrase's alignment. So, at random they selected 200 sentences, in the EE/N dataset obtained after alignment. If the pair was completely aligned, we marked it as aligned. If the pair was not completely aligned, for example due to segmentation errors, we considered it partial, otherwise. This part was carried out on all the aligned texts. We had to share in 4 groups all the texts for an effective alignment, and also seeing that the tool used only authorizes a quota of 15K sentences per alignment, Table 2. Of all assessed sentences, 96% on average were correctly aligned, while 3% on average were not aligned due to their emptiness. The small percentage, 1%, of invalid sentences is probably due to the use of the Neuronal algorithm with the dictionaries provided. Figure 2 shows the precision alignment for all batches of bilingual texts provided. The percentage of alignment is obtained by making the ratio between the number of aligned sentences and the total number of sentences contained in the target text. Machine translation evaluation. Before machine translation experiments, sentences were randomly divided into 2 disjoint data sets, training and validation. For the NMT experiment, we used the TensorFlow. 2. Marath, 2020, Tiedemann, 2010. Implementation of neural machine translation with Bahdanau Attention Mechanism on a Keras model applying GRU layer for the encoder and the decoder, with 1024 hidden unit and the word embedding of dimensions 256, on 100 epochs. The figure 3 present the attention plot for one sentence used as test for prediction. Below, is the sentence translated by our neural machine translation model and presented with the attention plot. We can notice that the translation proposed by our model is far different from the human translation. Input: Start new kate mwowa new sia. End human translation: Why do people do it? Predicted translation: What is old brothers? End. The shades of yellow and green suggest higher weights of attention to the corresponding words in the source sequence in predicting the word of the target sequence. Under-resource machine translation faces a problem of corpus size, since machine translation system needs a couple of million sentences to outperform. Unfortunately, the result obtained is far from being good or close to the state-of-the-art results for neural machine translation. And this is just our first attempt to build such a kind neural machine translation system from Ewe to English. Therefore, our model requires much more training and more data to arrive at an almost acceptable result. Evaluated bilingual corpus comparison. To make the comparison in relation to other bilingual corpora built from start to finish, we opted for the English-Spanish corpus with more than 789,547 sentences and the English-Portuguese with 711,475 implemented by Felipe and Martin. 2019, as well as for the English-Latvian from EU Bookshop corpus used by Zarya, Akiforovs, and Skadi, 2015. By comparing the quality of alignment of our corpus with other corpora, we can notice a satisfied result which corresponds to the average obtained by these corpora. In other words, almost 96% of the sentences of our corpus are well aligned. Conclusion and future works. We built a parallel corpus from different textual data in Ewe and English. Our corpus is based on textual data from various sources such as literary, religious, international law and website, which is full of texts in Ewe and English. The corpus contains the Ewe/English sentence pairs, Ewe dictionary, and bilingual dictionary. We provided a manual evaluation of sentences regarding alignment quality, with average 96% of sentences correctly aligned and a neural machine translation system using Bahdanau Attention Mechanism. For the future work, we will keep on building our corpus by providing more data to make our corpus richer, more structured, with a lot of annotated data to be used for work in natural language processing, such as part of speech tagging, named entity recognition, and building a better machine translation system than the current one ETCA.